In the aftermath of World War II, the Allied powers sought to unravel the secrets behind the cutting-edge German armor that had dominated the European battlefields. Among the many testing facilities utilized, the Henschel Panzerversuchsstation in Haustenbeck stood out as a trove of technological marvels. Here, the Allies examined an array of German tanks, prototypes, and experimental designs. Haustenbeck, located near the Henschel factory in Kassel, had been central to German tank development during the war. The company Henschel und Sohn, founded in 1810 in Kassel, was at the time the largest locomotive manufacturer in Europe. However, from 1933, Henschel became involved in the plans of the German Army High Command to equip the army with modern tanks. At the beginning of 1939, the decision was made to relocate the entire Versuchsabteilung, or experimental department, of the Henschel company from Kassel to Haustenbeck. The resources to convert the existing buildings and to build the necessary facilities came from the army. When the Versuchsabteilung moved to the town, large parts were screened off from the rest of the area by wooden fences to keep prowlers out. In addition, 3 police officers were permanently present to secure the grounds. The area was patrolled by military motor vehicles and dog patrols. Anyone who came close was arrested and detained. In reality, anyone who came near or had any contact with the residents of Haustenbeck was closely monitored by the Gestapo. One of the most interesting sites of the test center was the large submersion pool. It was originally built to conduct deep wading trials with the Porsche's Maus tank. The center was instructed to build a basin able to support a 200-ton tank in September of 1942. The cost of the construction was more than 250,000 Reichsmarks. Supposedly, a number of POWs from the nearby camp were used as forced laborers during the construction. To bear the enormous weight of the Maus, the bottom was made of 60 cm thick concrete. The dimensions were 18 by 60 meters, and at its deepest point, the basin was 6.6 meters deep. The entrance and exit had an increase of 15 degrees. By means of a dam, a reservoir was created from which water could be pumped into the basin. In an emergency, it could be emptied in 10 minutes. The entire construction was completed at the beginning of 1943. The facility itself served as a proving ground for tanks like the Tiger I and the Tiger II, as well as the experimental designs such as the E-series tanks. In April of 1945, the US Armored Forces were the first to confiscate the facility along with material and several prototypes. American and later British forces examined the material and used the facility for their own tests. When the Allied forces overran the area, they discovered prototypes and unfinished vehicles that revealed Germany's ambition to create machines capable of dominating any adversary. The E-100 One of the most striking discoveries epitomized this aspiration. Conceived as part of the Entwicklung series, the E-100 was intended to be the ultimate land battleship, boasting unparalleled firepower and protection. However, production had barely begun when the war ended, leaving only an incomplete chassis behind. The E-100 supertank, designed to weigh over 140 tons, was envisioned as a platform for a massive 150mm gun. Its formidable armor, up to 200mm thick, would have rendered it nearly impervious to contemporary anti-tank weapons. Despite its promise, the tank faced numerous practical challenges. Its sheer size and weight meant it would have been nearly immobile in real-world combat conditions, limited by terrain and vulnerable to air attacks. At Haustenbeck, Allied engineers were astounded by the size of the E-100 chassis. It represented a design philosophy focused on brute force, sacrificing speed and logistical feasibility for firepower and survivability. However, its unfinished state highlighted the shortcomings of such a wonder weapon project, which often demanded resources Germany could ill afford. In stark contrast to the E-100's large proportions, the British Valentine tank, also present at Haustenbeck, represented a completely different approach to armored warfare. Designed for speed, simplicity, and ease of production, the Valentine weighed just 16 tons. The two-pounder gun was modest but effective in the early war years, and its thin armor allowed it to maneuver where heavier tanks could not. The Valentine exemplified the Allies' pragmatic approach to tank design, which emphasized quantity over individual tank superiority. This philosophy played a key role in Allied victory, as the mass production of serviceable tanks like the Valentine and Sherman overwhelmed German forces numerically. The post-war test of the E-100 alongside the Valentine highlighted the stark divergence of design priorities between Axis and Allies. The E-100 was an engineering marvel, but its practicality was questionable in light of logistical and operational realities. By contrast, the Valentine was far less impressive on paper, but had proven itself effective and reliable in combat. The testing at Haustenbeck revealed much about the limits of armored warfare and the lessons of World War II. The Allies recognized that the balance between firepower, mobility, and logistical support was critical to success. Tanks like the E-100, while impressive in isolation, were ultimately too specialized and resource-intensive to make a meaningful impact. Today, the remains of these machines serve as reminders of the ambitions and excesses of wartime engineering. The post-war tests at Haustenbeck were not just about evaluating the hardware of a defeated enemy. They were a study in contrast, a clash of philosophies, and a blueprint for future innovation in armored warfare. I hope you enjoyed this episode. If you want to support my channel, check out the PayPal donation link in the description or consider becoming a member. To make sure you don't miss my future work, subscribe to my channel please and press the bell notification button. Thank you and see you in the next video.